could say displacement is equal to total distance, right? We can set up our integral from 0 to 7 of 3t squared plus 6 dt. Let's figure out what that equals. Here we don't want to do the p of b minus p of a thing because we're not trying to find a position. We're trying to find the total distance. If I integrate this, what would we get? I mean, we already did it. T cubed plus 6t evaluated from 0 to 7. So let's do it. 7 to the third plus 6 times 7 minus, if I put 0, what are we going to get? 0. So that's awesome. They were nice. They only gave us one hard one. 7 to the third, 343. Plus 6 times 7? 42. So 343 plus 42?
395.
I mixed them up. 385?
Yes.
Total, right? And that would be again feet or units or meters or inches, right? Whatever the unit is. Too easy? Okay, so that one right there was an algebraic approach, an analytical one. The next one is going to be a calculator question. So we want to take advantage of the fact that we have the calculator to help us answer the question. Okay? So here we go. The velocity of the particle moving along the x-axis is given by this function. Oh my god, it has e's and stuff. We haven't learned how to integrate e's. They're pretty easy. We'll do that later. But the first question says, if the position of the particle at 1.5 is 2.551, what is the position when t is 3.5? So we're looking for a position. We're given velocity. We know we need to set up a what? We've got to set up an integral in order to get that position function. What would my integral be? 1.5 to 3.5 of v of t, which I'm going to write out because I'm going to have to type it in my calculator. Make sure that you guys type it in there correctly. And I know that, what should that equal to?
2.551. Oh, no.
P of 3.5 minus P of 1.5, right? So that's going to give me P of 3.5 minus 2.551. This is a popular question on the AP test. It's going to come out. You've got to be able to set these up. And the more than likely will be on the calculator section. So how do I figure out the value of this? Put it in the calculator, right? It's calculator active. Alright, let her rip. You guys know where that integral is? The template button, right? Next to 9? Alright, type it in. Let's see what we end up with. Your stomach hurts? Did you eat a burrito? With frijoles? You could type this in the graph and then use the bars if you want to. Or you can just type it all in, right? It's up to you. T minus 2 squared. Ah, no. It's cubed, right? Oop, just kidding. I wrote it wrong. What do we end up with, guys? 15.919? Okay. So 15.9192. And now we're going to do what to finish this guy? Plus 2.551. So P of 3.5 is equal to, add it to what you got on your calculator. 18.470. We just need 3 decimals, right? And again, that would be a position, so that would be units or feet or inches. Good. Part B. What is the total distance? Boom. As soon your total distance, what are you thinking? Always positive, so absolute value, right? Okay, we're not gonna check to see if it's only, if the velocity is always positive. I'm not gonna worry about that. I'm just gonna plug it in because I have my calculator. So it's gonna be the integral from where to where? 1 to 5. But now I'm gonna make sure and put that absolute value of that 0.5 e to the t times t minus 2 q dt. And I want to figure out what that is. Boom, real quick. Maybe the velocity was always positive. I'm not going to take that risk. I'm not going to graph the velocity curve to find out when that happens, because it's a calculator active question. Yeah, it was cubed. I wrote it wrong. I'm sorry, Angel. Forgive me? Okay. The absolute value is under the template buttons as well. Okay, don't put the little bar that's right there where the equals is, because that's a different bar. That's a such that bar. You could go up and copy what you want to paste in the absolute value, but I don't think it just lets you add the absolute value. Should be a large number. 900 something. 913.067, yes, you didn't do anything wrong. Good? Super easy? You got 912?
My work is for midterm, it's like right after. I memorize the thing. Well, I'm gonna go see if I actually memorize it. No, she just made everything easy. Like we were doing it right now. We just have to like memorize it. Because it's the same ones on the review, but we don't have a review. Like, it's
Oh,
online.
you didn't put absolute value.
But we don't know where it is. Yeah, but like we can't review unless we go. You are gonna go to school? Yeah. Well, we're gonna do some stuff and then I'll come to read to the lab. So you're gonna give me a 9. I helped her. She's gonna give me a 9, and then I didn't help her. I think Elmer took a picture.
Yeah, be careful, okay? You were finding total distance, so you needed that absolute value.
You tried. No,
Alright, are we good?
You found the.
Alright, so we did one by hand, one on the calculator. Now let's do another one by hand, but now we're given a graph. Okay? So it says the graph of the velocity measured in feet per second. Okay, so now they are providing units, so make sure we put units in our answers. If that's the velocity, what would the acceleration be? Feet per second squared. What would the position be? Feet. Very good. Okay? Don't mess it up. Right? The position of the particle at 8 is 12, so that means P of 8 is equal to 12. Use the graph of V of t to answer the questions that follow. So it says, what is the position at t equals 3? So I'm looking for P of 3. So in order to find position, given velocity, I need to set up an integral. What would my integral be?
3 to 8.
From 3 to 8, the one that they want and the one that was provided, of V of t dt should end up equaling what? P of 8 minus, beautiful. I know P of 8 is 12, minus P of 3, I don't know, that's what I'm solving for. And how in the world am I going to calculate that? Look at the graph, right? So I'm going to look at the graph, and I know that this represents the bounded what? The bounded space from where to where? From 3 to 8. So I need to find this space, and I need to find this space, and I need to combine them, right? Okay. So we're going to use the graph, right? We're going to find the bounded space. Oh, back to geometry. Finally we use it. So, how do I find the area of this space right here? Trapezoid, I could do a rectangle and a triangle, right? Wanna do that?
Yeah.
Okay, so the rectangle, what would it be? That would be 1 times 5, so that's 5. And then the triangle? 5 times 2, 10, divided by 2, that's 5, so 5 and 5, 10? Yeah. This one's also 10. How about the triangle? 2 times 2, that's 4, divided by 2, it's 2, but it's gonna be what? Negative 2, because it's where? It's on the bottom, right? Okay. So what would I end up with here in this case? 10 minus what? Minus 2, which is 8. So 12 take away what is 8, Dominic? Yes. Or usually they say that in golf sometimes. Why do they say 4?
Before you hit it, so that people can like do.
Oh, so they get out of the way?
Yeah, so like.
4!
Cool.
Yeah, get out of my way.
Why not say 5?
Because it's like a theme,
Or
so that you
6?
know that. I don't know.
Or 7?
Why do they yell timber?
I like 7!
Why do they yell timber?
Because the tree's gonna fall.
Oh, really?
It's kind of like yelling 4.
Why do they yell timber?
Yes.
All
Alright. Let's look at B. We're almost done. We're almost done. Focus. B. What is the acceleration when t equals 5? How do I find acceleration? The derivative of velocity, right? So v prime of 5 is what I want. And when I'm finding a derivative on a graph, it's like finding the what? The slope of the tangent line, right? At 5 in this case. So if I go to 5, and I were to draw a tangent line at 5 on the graph, what would the slope of that tangent line be?
-5/2.
So the tangent line would end up being on top of this one, right, Anna? Therefore, giving it the same slope as that one, right? So what would the slope of that one be? -5 over 2. And what would the proper units for that be?
Feet per second squared.
Feet per second squared. You good, hubby? Alright, part C. What do they want there? What is the displacement? So what do I need for that one? Do I need an absolute value on it?
No.
No, right? That one is just the integral, right? So set up your integral, because they're going to want to see the setup. So it's the integral from where to where? 0 to 10 of the velocity function. And what is that going to equal? So we're going all the way from 0 to 10 now.
So 20 minus
So
4, 16.
20 minus 4? 16, and it would be 16 what? Feet. So what this number tells us is that the particle was moving more to the right than it was to the left. That's why my final answer was positive, right? Cool? And the last one, letter D. What is the total distance the particle travels from t equals 0 to t
You
equals
need to
10?
make the 4.
24.
So total distance, now we want what?
The 4.
Absolute value, right? So it's going to be the integral from 0 to 10, but now
Value will be PDT.
What?
absolute value of velocity. So now we're going to imagine that this triangle right here, when I get the absolute value of this graph, that's going to cause that triangle part right there to flip up, right? And now we'll have a bounded space of what?
24.
4, so it'll be 20 plus 4, which equals 24.
Do you have to, on the text, do we have to rewrite the... the VFT, as an absolute value, even though, like, we know what it is? but we
Yeah,
don't
they
know
wanna
what it
see
is?
the setup.
Oh, okay.
Even if it's the calculator section, they wanna see the setup, 'cause they might give you partial credit for that,
Uh-huh.
and then another credit for the actual dollar.
Oh, okay.
Okay,
So,
cause this tells them that you knew what to do, but then you got the wrong number, so that means you didn't know what to do on your calculator,
Oh, okay,
right? So
cool.
you messed up typing it in, but you're still gonna get a point, cause you knew the calculus, you knew how to set up the problem, how to get the answer.
Right.
You just made a mistake somewhere along the way and didn't get the right answer. You understand?
Yeah.
So they're out to see if you actually understand the calculus, or if you're just there to like do whatever your teacher told you. Okay? Cool? Alright, so I got one more problem, so we did one by hand, we did one on the calculator, we did one with a graph, so we're missing the one with the table. Okay, so I'm gonna give you one with the table. And that's your homework.
Hey.
Okay?
So when's the quiz?
What's the quiz? You wanna have it on Wednesdays?
Yeah.
Yeah, Wednesday's good.
Or you wanna wait till Thursday?
Next week. Here? No? No?